All right, lecture 3, line angle formulas. Now this is taken a little bit out of order with what we currently have in our book, but it's because it's really important to know, and these save us so much time drawing when you have to draw them on the exams, and for me to create the exams. And if you see this, if you're in the health field, you're going to see molecules occasionally. They're always going to be, the organics are always going to be drawn as line angle structural formulas. The reason I'm kind of going on about this is that in each class that I teach, there's always 2 or 3 students that simply they don't want to learn how to do this. And they draw everything out as expanded or condensed structural formulas. It wastes so much time. And then when I put a line angle drawing on the exam, which I do for most of it, they're not quite sure what's going on. Very important. If you have to watch this thing 10 times, watch it 10 times. If you don't get it, ask me or your instructor. Show you what's going on. Very, very important. Now, a line angle structural formula, you can see here we have the condensed ones. I'm asking you to draw them as a line angle drawing. Now, the molecules, the organic molecules, say one carbon, let me get up here, carbon to another carbon like this. This bond angle is 109.5 degrees. There's a kink to it. And so we've been drawing the carbons like this. They don't occur in a straight line. Can't have it in a straight line. As you move along, carbon to carbon, there's always a bend as you go. This is 109.5 degrees and so on. So when they say a straight chain molecule, they're kind of lying to you. You can never get them in a perfectly straight line. There's always that kink. So they take advantage of that structure. And what you do is that anytime, if you want to draw this, you have 3 carbons. You have a carbon, carbon, carbon like that. That's how it would, if you get rid of the hydrogens, that's what it would look like. That's the form it would take. And then instead of putting in the carbons, just do this. Any kink, the top of the kink is a carbon. Any ending is a carbon. And any intersection is a carbon. And then we don't have to draw the carbons anymore. And they say, well, what about the hydrogens? Well, you know that carbon, if we draw a line angle structure and there's nothing, we don't have a chlorine or something in there, then we assume that everything is just carbon and hydrogen. This is a hydrocarbon. This carbon, how many bonds does it have? Well, we see 1 to this carbon, so there must be 3 hydrogens on there. This has 2 bonds already, so there must be 2 hydrogens here. And we see that we get back, if we put the carbons in here, we're back to the original molecule. So instead of drawing out, even the condensed form can get to be quite nasty. As you'll see, I'm going to give you several examples. So let's learn how to do it in a very a shortened form, abbreviated form, and the form that's used by anyone who's in this field. They're not going to draw all this stuff out unless they have to for one reason or maybe some reactions they might want to show all of the atoms. But otherwise, this would be drawn like that. And no, I put the little circles to indicate the carbons. There's nothing there. It's just that. Now, how about this guy? Well, we have 1 carbon, 2nd carbon, 3rd carbon, 4 carbons. You can see that you have the 2 ends. Those are carbons there, and those are CH3 groups. There's only 1 bond to it. So there's 3 hydrogens on there, and each kink at the top or the point of each kink, that's a carbon as well. Since that, you can see there's 2 bonds going off, and that's what these lines indicate, the bonds. There's 2 bonds here, so there must be 2 hydrogens. And we're going to take the line angle formulas and go back to the original molecules as well. How about this guy? So it's 1, 2, 3, 1, 2, 3, 4, 5. And that's pentane. So we have propane, butane, pentane. Hexane would just be that. Heptane would just be this. Octane, so we just go right down the line. So you can have something, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if you have a chain of 20 carbons, there it is. So you just have to be careful about counting them up. That's one thing that gets the students sometimes on exams, is that they put one too many lines on there. Now what about this guy here? Well, we have a carbon in the center, carbon here, here, here. Now here, we have to have 90 degrees because we're showing we don't have 3 dimensions to work in. So, but when we have this where there's a carbon that's connected to 4 other carbons, you're going to have this plus sign. And so you recognize that there's a carbon on each end, and then there's a carbon in the center. So as I said, the ends, the kinks, and the intersections all contain carbons. Let's go to something a little trickier. Lots going on here. So what I normally do is I find the longest chain, 1, 2, 3, 4, 5, 6, or appears to be the longest chain. So 1, 2, 3, 4, 5, 6. Then go 1, 2, the second carbon over, there's a carbon, so I go up, and there's a carbon to each side, boom, boom. And then on the third carbon, there's a carbon here, like that. And now, we'd like to keep the same, that 109 degree angle, or approximately, but you can always leave it in the same form that they have here. Just do this. Actually, you probably, no, we want to be, we could leave it, I could just draw it like this. And you do see it that way. You might want to actually put in a bond, the angle like that, just so that there's no mix-up. But you could certainly leave this branch as, because there'd be an intersection there to tell you there's a third carbon. So yeah, nothing wrong with that. I'll redraw it like that too. As I was looking at it, seemed okay to do that. Then we have 1, 2, 3, I have a methyl group here. So we could also draw it like this, sticking with the same kind of basic structure that you're seeing already. But remember, these are flexible molecules, and we're allowed to move this bond around. This one is certainly okay as long as you recognize there's a carbon right there. It shouldn't be a problem. All right, how about this guy? And I just made these big molecules up on a Chem Sketch program. So I haven't looked at them yet until now. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Then on the second carbon, there are 2 methyl groups. How you normally do it, you could do one above and one below, but normally you just put them like that because that's closer to the angle they'd have. The third carbon is straight across here, but it's pointing down, so the methyl group. And I should say there is nothing wrong with this, doing it this way. And sometimes you'll see that in depending on what the organic chemist is trying to accomplish. This is fine, but it's a little weird looking, a little messy, a little crowded. This is a better way if you have that choice. This guy, I already have it set up pretty much like it should be. So it's 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. We have a methyl group up, methyl group here, methyl group here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I would really advise you to double check, triple check all of your work. Don't get focused, on just one problem, but check it. Once you're done, double check it, and then go do the rest of the exam. Then come back and triple check. It's always a good idea. You can kind of get lost in the counting here sometimes. All right, for this one, what I do on an exam, if I were taking, I'd circle the main chain that I was after, just to make sure I didn't reuse any carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it could get this bad on the exam, probably not. 3, 4, 5. But it's really not difficult. It's just, now it's just you have to manage all of these carbons. So on the second carbon in the chain, you have 2 methyl groups. I'm going to put a square around them. I'm just doing what I normally do, just to keep track of them here. This guy is there. We leave this methyl carbon alone. This one has a methyl group on it. This has a methyl group. This one has a methyl group. And remember, see, the methyl group is just, it's CH3, but it's just a line up. And then we have a carbon here. And let's just verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10. Boom. There, 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 there. All right, now this monstrosity. So a lot of times I'll give you, after we've covered a few of these problems, even though it looks like we're going really fast, you can always go back and double check the book, look at some easier problems. But I like to give a couple of tricky ones, just to verify. Now, leave that. This is actually the longest chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 member one as well. 2, 4, 6, 8, 10. And then off the third, so I'm going faster because I know what I'm doing here. All right, I think I do. But you can always slow it down. Don't be afraid to go back. Double check everything. Now here's where I got to be careful. So 1, 2, 3, 4, 5, 6, 7. On the 7th carbon, 1, 2, 3, 4, 5, 6, 7 is when we diverged off to an isopropyl group. You might not know it's an isopropyl group yet. You will. So it looks like everything's on there. And 1, 2, 3. Yeah, looks good. All right, let's go the other route. Yeah, on the exam, I probably wouldn't go quite that crazy. But I'll give you probably around 15 or so atoms to work with, 12, 15 atoms to work with. Now this one, let's go back the other way. We want to create the condensed structural formula. So you can see at each point here we have a carbon. Each ending is going to be a CH3. In the center here, it depends on how many bonds there are to it. So this carbon, this is a CH3. It's bonded to this carbon. And this carbon is bonded to a methyl group, so we might as well put it on here. And I put it above, it's below here. Don't let that throw you, it can be one or the other. Now we're back to straight chains. And then it's going to have an H, and it's connected to this, which is a CH2, connected to this guy. And it has the same methyl group. And you say, well, these methyls were below. Remember, it's free to rotate in space. I could have put the methyl groups down, make it easier to see the relationship, but yeah, I'm not upset that I put them up above. You should know that it's the same exact thing. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 methyl groups on the second carbon from each end. Everybody has four bonds, so that's good. Oh, I'm not kidding around, am I here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have C8. Actually, I'm going to just do 9 carbons here first. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the ends are methyl groups. Now, we see we start here. This is carbon 1, 2. At 2, there's a methyl group. And then 3, 4, 5. At 1, 2, 3, 4, 5, there's 2 methyl groups. And then at carbon 6, there's an isopropyl group. I haven't left a lot of room here, so we'll have to do this. If I had a chance, I'd redraw that, but it's okay. The bonding is there. It's just a little messy, but that's okay. And if you're asking, well, will you allow me to be messy on the exam? Yeah, as long as I can see what you're doing. I know that you're under pressure, time constraint, but you should also be writing in pencil. But yeah, as long as the bonding's there. You can see all the bonds. So here, find that longest chain. Might as well get used to that because that's what we have to do for the naming, which I think is the next lecture, or one of the next. Find that longest chain, 1, 2, 3, 4, 5, 6, 7, 8. And you might say, well, those big molecules you had before, those were all over the place. Can't we just put the carbons? Yeah, sure, absolutely. But it's, you can put them all over the place just like this. I wouldn't suggest writing on the molecule. You can do it over here and make it look like the same shape. The reason I convert over to this the linear kind of form is it makes it easier to keep track of everything. So 1, 2, 3, 4, 5, 6, 7, 8. Probably right now I'll leave off the bonds just because I know I'm going to have to add the hydrogens in. So 1, 2, 3 at carbon 3, 1, 2, 3, there's a methyl group. 4, 5, 6 at 1, 2, 3, 4, 5, 6, there's 2 methyl groups. And that's it. So then finish it up. This has a hydrogen. And this is, that's right. And just keep track of how many hydrogens you have. I think everything's in there as it should be. I'm using a thicker pen than usual, so I got to remember to kind of expand things out a little bit more. But these are big molecules. That's causing the trouble. All right, so let's see. Find the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what I'd normally do. I'm just going to approach it like I would on the exam. I'm going to try to spread this out so we have lots of room. Keep picking these monster molecules. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can put CH3 on the ends. because I know that's what they're going to be. Then we have 1, 2, 3, 4, 5 at the 5th carbon from this side. 1, 2, 3, 4, 5. We have a methyl group. At the 6th one, we have a methyl group. Now, I could put the methyl group above or below. I'm going to put it below because we have room for that. If I put them all above, it'd be very messy. It'd be really crowded. But you're free to do it. You can put them above or below. It doesn't mean anything. It's just a conformer. So as long as the bond is there, it's the whether you put them above or below, it means the same kind of molecule. So 1, 2, 3 looks good. And then we have this guy, 1, 2, and you should be, I should say 5, 6, 7, 8, 9. These are for you. I know how to do this stuff already, strangely enough, but I'm going to do these out so you can see it. But if you understand what I'm doing here, don't just sit back and watch me doing this. You know, where you're doing something else, you're driving your car or something. Try to do these molecules beforehand. And if you say, "Well, it looks easy enough," I said, "Try it, because you might as well try to do it now with no pressure than be the first time you ever do them on the exam." So, "Well, I thought I knew what I was doing." Try it out, make sure. So 1, 2, 3, 4. I think that happens to a lot of students. They think they have it, and then they get into the pressure situation of the exam, and they don't remember because they haven't actually tried it. They just watched me do it. Big difference between the two. Okay, so this is methyl group, and then I'm going to put the ethyl group below. And you should learn these names, the ethyl and methyl groups, the substituents we're about to deal with in the next couple of lectures, and that is the deal. I think that's everybody. Good. So lots of practice. So that's what I tend to like to do on these videos, give you a ton of these problems to do. Try to do them. Once you understand what's going on, when I put up another problem, pause it, try to do it, and then I'm going to do it. Might as well check and see.